So we got this topic, and this topic is very important in terms of IIT Advanced examination. Okay, these are the points where you will make mistake. Okay, so it's suggested that try to memorize these properties because the questions in which it has to be applicable, no, it won't click in your mind if it is not by heart. Okay, so I'll go through the each and every property one by one, and you have to understand these things, okay, and try to memorize these situations. Okay, now look at this. So look at this word, focal length. Okay, so what is focal length? Distance of focus from the point on the curve. Distance of focus from point on the curve. Okay, now suppose that this is your parabola. Okay, and you know that this is your focus. Okay, so suppose that you are trying to draw a circle whose diameter is the focal length. Okay, we have drawn a circle with diameter as focal length. Okay, this circle will touch tangent at the vertex of parabola. Okay, so your circle will touch this this tangent to the vertex. Okay, look at this. So suppose that this, like, look at this, just assume that it is touching. Okay, wait, I'll manage. Suppose this is the thing, suppose this is the diameter. Okay, so you will have a tangent, tangent and vertex will touch the circle. Okay, now we have second point, like we have to draw a circle with focal chord. Okay, focal chord as diameter. Okay, this circle will touch. Okay, so it is talking about touch, not cut. Touch the directrix of parabola. Okay, so if you have a circle whose diameter is focal length, this circle will touch tangent at vertex. If you have a circle whose diameter is focal chord, then this circle will touch directrix. Okay, I hope this property is clear now. Now look at this reflection property. reflection property. Okay, now suppose that you have a parabola. Okay, so suppose that there are so many parallel lines are coming. Okay, parallel to axis of the parabola. So after striking the surface, it will conclude at the focus. Okay, so after striking, it will conclude at focus. So it is incident ray, it is reflected ray. I hope this property is also clear. And if your ray of light is coming from this direction, so after reflection it will reflect back. Okay, and it will appear that it is concluding at the focus. Okay, I hope this property is clear now. Now suppose that you have a parabola. Okay, suppose that you have a parabola and you have drawn a tangent. Okay, suppose this is the tangent. At this point you have drawn tangent and this is the focus. Okay, so from focus, if you will try to drop foot of perpendicular to any tangent, okay, this is any point. Okay, so you have taken a random point on the curve to which you have drawn what? You have drawn a tangent. Now you are trying to draw foot of perpendicular on the tangent, so that foot of perpendicular will be drawn at tangent at vertex. Okay, so this thing is tangent at vertex. Okay, so at any point you will draw a tangent. Now on that tangent, if you will draw foot of perpendicular from focus, that will conclude at tangent at vertex. I hope this property is clear. Okay, now look at this property. Suppose that you have a parabola to which you have drawn a tangent at any point. Okay, now suppose that this is the directrix. Okay, and this is the focus. Now I am talking about this situation, the portion of tangent till the directrix. The amount of angle, I'm talking about amount of angle. Okay, like suppose it is A, it is B, so I'm talking about angle ASB. Okay, so this angle I'm talking about, so this angle will be 90 degree. Okay, is that clear? Now I hope till this part you guys are okay. Now suppose that you have a parabola. Okay, and randomly you guys have taken 3 points. Okay, so point number 1, and you have drawn the tangent. Point number 2, you have drawn the tangent. Okay, so I'm talking about A, I'm talking about B, and I'm talking about point C. Okay, so I'll change the color of these alphabets. Okay, so look at this: A, B, and C. Now look at this. you will have two triangles. Triangle because of those tangents. Okay, so this is the triangle, and then you will have a triangle inside the parabola. Okay, so I'll be taking some different color. Look at this. I'm talking about this triangle. Okay, so we will have two triangle, outside triangle, inside triangle. Okay, so there is relationship in the ratio of area. So it is area of inner triangle. Inner triangle is equal to 2 times area of outer triangle. Okay, so this property you have to memorize. Okay, I'll repeat again. So suppose that if you have a circle whose diameter is focal length, so your circle will touch tangent at vertex of the parabola. If you have a circle whose diameter is focal chord, so your circle will touch directrix. If you will draw a parallel lines to axis of the parabola, after reflection those lines will strike focus. If you will draw tangent at any point on the curve parabola and you will draw foot of perpendicular on that tangent, so it will conclude at tangent at vertex. Then the angle subtended by the portion of tangent by directrix and the point at the focus will be 90 degree. Okay, and if you will select 3 points and you will draw triangle because of tangent, or that triangle will be outside the curve, and a triangle inside because of those 3 points. So area of inner triangle will be 2 times the area of outer triangle. I hope you can memorize this thing, and if it is like try to go through it one more time. Okay, but try to memorize this thing. This is very important. Okay.